Thank you very much.
Thank you very much. For next meeting.
See you.
Good morning, ladies and gentlemen. My name is Bogdan Kornienko. I am a professor of Igor Sikorsky Kyiv Polytechnical Institute. I am today one of moderators of our track. Our track called Information Technologies and Artificial Intelligence. And I am happy to introduce you chairman of our track, Professor Alexander Rolik, head of Department Automatic Control and Technical Systems of Igor Sikorsky Kyiv Polytechnical Institute. Alexander Ivanovich, please, your word.
Can you see my presentation?
Yes, yes.
Dear participants of the IEEE 2020 conference, colleagues, friends, I am Alexander Rolik, chair of track 4 and head of the Department of ACTS, National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. This session of track is devoted to 75th anniversary of ACTS department of Igor Sikorsky Kyiv Polytechnic Institute, and I want to thank the conference head Alexander Yudin to devoting the conference to such a significant event in the history of our department. The department was founded in the Faculty of Electronical Engineering of KPI back in 1945. Society demanded the saturation of industrial and the scientific branch, the specialists of electronic and devices and system of automation and telecommunication at that time. This area was later referred to as monitoring and remote control system control in technical systems. The first issue the department was made in 1948. The department was named as Automation and Telemechanics in 1963, and since 1984 has equal the model name of Automation and Control Systems and Control in Technical Systems. Sorry, the department has developed strongly in education and scientific areas during these decades. The department has become the basic for formation of the Department of Computer Science and the Department of Technical Cybernetics. Significant methodological and scientific work was performed at the Department of ACTS. The department has trained many thousands of specialists of this field. The department worked closely with enterprise, research institutions, and performance significant amount of economics work order. Scientific and pedagogical schools were established of the department by Professor Grebin, founder of the department, Katkov, Krasoproshina, Serdyuk, Zhurakovsky, Podlipensky, Telenik. These teams continue to make significant contribution to the sustainable development of the society and to the research and pedagogical image of Igor Sikorsky Kyiv Polytechnical Institute. Today, a highly qualified scientific and pedagogical teams work at the Department of ACTS with combined the wisdom of experience and energy of youth. The ATIT 2020 conference is another significant step of our development on the track for which is supervised by the Department of ICTS. 37 materials were submitted and only 22 were occurred. This is evidence of high scientific requirement of the conference materials. Thank you for your attention.
Thank you, Alexander Ivanovich, for your word. Have you any questions to Alexander Ivanovich? Thank you. Okay. Then we start next our report, and I want invite to speak Artem Kramov and Sergey Pogorely, report evaluation of the coherence of Ukrainian text using a transformer architecture. Please.
Good morning. My name is Artem Kramov, and I'd like to show you the presentation with the topic Evaluation of the Coherence of Ukrainian Texts using a Transformer Architecture. Firstly, let's consider the essence of the problem. The coherence of a text should be considered as a separate feature. It interprets the semantic connection between the different parts of the text. All sentences, phrases, or words should be connected with each other in some semantic and logical way. In order to convey the communication purpose of a text to a reader, it is necessary to comply with the consistency of its parts according to background knowledge. Coherence evaluation is widely used in different areas, like CO analysis, different copywriting tools, and even in the medicine area. Coherence evaluation falls into a category of natural language processing tasks. So in order to solve it, different machine learning techniques, namely deep learning models, should be utilized. The goals of the work are the following: analysis of state-of-the-art and baseline deep learning methods of the coherence evaluation, using of the encoder part of the transformer model to design the neural network for the coherence evaluation of Ukrainian texts, examination of the effectiveness of the trained model in comparison with other deep learning methods. The comparative analysis of different state-of-the-art coherence evaluation models is considered in our article in detail. According to the disadvantages of these models, we suggest a new coherence estimation model that can take into account connections between the words within the sentence and can solve the problem of vanishing gradient during the learning process. First, let's consider inputs and outputs of our model. Text T is represented as a set of groups of sentences, so-called clicks. Each click consists of 3 sentences. The output value of the module is represented as scalar value that denotes the coherence of the text T. As can be seen from the formula on this slide, it is calculated as the average value of the coherence of the clicks of this text. This slide demonstrates the general neural network architecture. Firstly, each sentence is passed through a sentence model that transforms this sentence into its vector representation. Then all three vectors are combined together into one common vector using the concatenation layer. Then this vector is passed through two consecutive dense layers that denote a simple binary classifier. The output value of this binary classifier represents the coherence value of all input sentences. As can be seen from this architecture, the sentence model should be considered as the main part of the whole model. Let us show how it works in detail. In order to take into account word order within a sentence and to detect the connection between them, it is suggested to use the encoder part of the transformer. In contrast to other typical sequence-to-sequence tasks with an encoder-decoder architecture, the transformer doesn't include any RNN or CNN components, so all words are passed to the input separately. This slide shows the structure of the encoder part of the transformer model. It can be seen from this slide. Firstly, all inputs are passed to the input embedding. Then the positional encoding is applied. The positional encoding applies the generation of an additional vector using some predefined algorithm with the further addition of it to the embedding vector. The following formulas are shown on this slide. The next component is multi-head attention. It should be considered as the main part of the encoder because it allows revealing some connections between words within a sentence. This slide shows the example how multi-head attention works. We can see the example sentence like, I cannot use this phone because it is broken. As can be seen from this slide, the multi-head attention mechanism revealed the connection between words like it with words phone, because, and broken. In order to train our model, it was decided to collect Ukrainian news from Ukrainian news portal. In order to compare the effectiveness of our model with other approaches, it was decided to implement the sentence model using simple recurrent neural network and convolutional neural network. This table shows comparison of different methods for the solving of typical coherent estimation tasks, document discrimination task, and insertion task. As can be seen from this slide, our transformer-based models shows competitive results via solving document discrimination task and outperforms other models for the insertion task. It is worth to lay emphasis on the insertion task because this task, namely the insertion of a sentence into its appropriate position within a text, correlates with the analysis of a text by a human. In contrast, document discrimination tasks imply the comparison of the original version of a document with its randomly generated order of a sentence. So it doesn't compare the text that was previously generated by a human. According to the analysis state-of-the-art coherence evaluation methods and the results obtained, the following conclusions can be drawn. In contrast to baseline convolutional neural network and can be parallelized. The proposed end-to-end model can be trained on the text corpus of other languages, as it doesn't have any severe dependency on external tools or models. The matrix updates may indicate that the proposed model outperforms baseline models while solving a typical insertion task. So it may be used to estimate the coherence of either Ukrainian or foreign language texts. Thank you for your attention.
Thank you for your report. Have you any questions?
I have a question.
Yes, please.
Please explain how you establish the connection between words.
The connection between words is established using the multi-head attention component of the encoder part of the whole transformer architecture. How it can be done? All formulas are described in our article. In a nutshell, each word is represented using 3 different matrices, so-called query, value, and key matrices. Then this mechanism is trying to reveal some connections between all matrices of all these words. Each head has its own matrices. So for instance, one head can reveal the dependency between, for instance, nouns like each, phone. Another head can reveal dependencies between verbs, it, broken, and so on. So each word is represented by 3 matrices, and using these 3 matrices and softmax mechanism, the connections between words are revealed.
If I understand correctly, you have a software to do this?
Yes, yeah, of course.
In English or in Ukrainian?
Software. This neural network and the training mechanism was written using TensorFlow library. But as for the data set, we investigated the Ukrainian corpus, the corpus of Ukrainian use.
Thank you.
Thank you.
Question.
May I ask one question?
Yes, please.
Can you tell how you can estimate the efficiency of your system? How do you assess?
The efficiency of our system was estimated using 2 approaches, 2 different tasks, a so-called document discrimination task and insertion task. Document discrimination task implies the comparison of the original version of a text with the permutated one, with the text where all sentences are permutated. So it is just the comparison of the original text with the text that was, for instance, written by machine. As for the insertion task, it implies comparison between the original version of a text with the text where one sentence was extracted and inserted into other position. And these values indicate the value of the correctly recognized text over all texts. So all the range of these values between 0 and 1.
But how you can estimate, for example, not just only words, but the idea of the text? Is it deformed or just how it's estimated really? Is this maybe some idea just shifted or something like that?
Firstly, I'd like to mention that this model should be considered as semantic based. So in order to understand that this text, that the idea of this text is single, this model is trying to check if the semantic connections between sentences and its component is strong. Also, we have other approaches. For instance, we have built in our previous research the graph of phrases. So we were trying to investigate whether the connection between phrases of each sentence can describe the semantic integrity of its text. But it's another approach. In this paper, we were trying to investigate the semantic connection.
Okay, thank you very much.
Thank you for the question.
Yes, thank you. Have you questions for the? No questions. Thank you for your interesting report.
Thank you.
And I want to invite to speak next report Dmitry Klyushin, Katerina Golubeva, non-parametric multiply comparison test for change point detection in big data.
Do you see my screen?
Yes, yes.
Thank you. Dear colleagues, our report is devoted to solving the problem, the test of finding change point of a time series using non-parametric methods for testing hypotheses. Change point detection problem is the problem of detection of point in a data stream or time series where distribution of data changes its location. The problems of change detection often arise in the context of using IoT technology to monitor the health and movement of people with COVID-19. Specifically, they describe the change in oxygen saturation as measured by pulse oximeters and the deviation from the reference point as measured by GPS. As a rule, the time series analysis is a big data problem connected with storing a huge volume of information. Thus, offline algorithms for analyzing complete time series often are impossible or ineffective. Hence, we must develop online algorithm of time series analysis allowing detecting change point, outlier, pattern, trend, etc. The most effective online statistical methods for solving such problems are the non-parametric methods for testing statistical hypotheses, namely Kolmogorov-Smirnov test, the Wilcoxon signed rank test, the sign test, the Mann-Whitney test, the Kraskell-Wallis test, the Friedman test, and the Page test. Considering the conditions of use of the tests, as alternatives to the test proposed in this work, we have chosen the Kolmogorov-Smirnov, the Wilcoxon signed rank test, the Mann-Whitney test, and the sign test. The other tests are just a modification of these tests. The purpose of our work is to describe a new approach to change points detection in a data stream and demonstrate its effectiveness comparing with the alternatives. Slide 4 describes the Klyushin-Petunin two-sided test of homogeneity. It uses the Hill's assumption and the Wilson confidence interval for a binomial proportion. We apply the test to compare the control sample with window sliding along the time series and then average their homogeneity measures. It allows applying the Klyushin-Petunin test to small samples. The asymptotic significance level of this test does not depend on the truth of null hypothesis. The sensitivity and specificity of this test is higher than for the counterparts. However, due to asymptotic nature of the test, it provides a significance level of 0.05 only when samples are large, i.e. when n is greater than 39. Thus, it is necessary to develop the variant of the test which allows testing of samples of small volumes. Slide 5 describes the classical Kolmogorov-Smirnov test using a deviation between two empirical distribution functions. The Kolmogorov-Smirnov test is quite sensitive to differences in the samples. Yet, for comparing two empirical distribution functions, it is necessary that the sample sizes are greater than or equal to 50. As the sample size increases, the accuracy of the test increases. If the sample size is small, it is advisable to use other tests, such as Wilcoxon or Mann-Whitney test. Slide 6 describes the Wilcoxon test using inversions of joint sample arranged in increasing order. This test is very effective for testing homogeneity of two samples with different means, but it fails when the samples have the same mean but different variances. The change of distribution of time series have two possible forms: change of the mean and change of the variance. The first case arises when, for example, the saturation of oxygen in blood decreases. The second case arises when, for example, the pulse of person varies during physical activity. In mathematical statistics, the first case is referenced as a hypothesis about shift of distribution location, and the second case is the hypothesis about scale of distribution location. Our experience was carried out to verify the performance of the proposed test. In our experiment using a pseudorandom number generator, three groups of training samples were generated from population of normally distributed random variables, N01, N02, and N11. To study three possible cases, homogeneous samples and two forms of heterogeneous samples. The size of each sample is 10. Each group consists of 10 samples. A control sample is a sample from the general population N01. The null hypothesis states that the control sample is drawn from the same generation as the training samples. The p-values, the probability of rejecting the true null hypothesis, as well as the actual number of errors of the first and second kind, were chosen as indicators of the quality of the tests. As follows from the table 1, when comparing a sample from the general population N01 with 10 samples from the same distribution, all tests accept the true null hypothesis. However, the p-value of all tests except for p-statistics varies widely. At the same time, p-statistics were very stable and did not go beyond the range 0.016, 0.84. When comparing the test with samples from the distribution N02, the Kolmogorov-Smirnov test, the sign test, the Wilcoxon sign test, and the Mann-Whitney test failed. The third group of samples drawn from the general population N11 is the most favorable data set for all the tests. It is well-known fact that the Kolmogorov-Smirnov test, the sign test, the Wilcoxon sign rank test, the Mann-Whitney test, in fact, test the hypothesis of a shift of distribution location. At the same time, it should be emphasized that the test based on p-statistics is more universal. As expected, all the tests except the Clusian-Petunia test based on p-statistics rejected the false hypothesis with a very low p-value, less than 0.301. P-statistics also indicate the falsity of the null hypothesis, but the more greater p-value. Conclusions, we may conclude that the new online algorithm for detection of a change point in a data stream based on the Clusian-Petunia test is specific, sensitive, robust, and universal. Its asymptotic significance level does not depend on assumptions about distribution of samples and does not exceed 0.05. It is equally as sensitive to changes of distribution location and to changes of shape of the distribution. In the two sample case, it requires saving only 40 or more current elements of data stream. Thank you for your attention.
Thank you very much for your interesting and actual report. Dear colleagues, have you any questions? No questions, yes? No. Okay, thank you for your report. And I will invite to speak next our colleague Mikhail Polishchuk, Mikhail Tkach, Information Technology for the Recognition of Semi-Precise Minerals. Is here? Not here, yes. Maybe later connection to us, and I will invite next our participant, Sergey Denisov, Vladimir Semyonov, Yana Vedel, report called Adaptive Algorithm for Variational Inequality Problem over the set of solutions if equilibrium problems.
Hello. Just a second, I'll share my screen.
Okay.
Everything is okay? You see my screen?
I see.
Yes, it's okay.
Yes, okay. I want to present our work with such a complex name. I will not repeat it. It's about solving, just a second. This work was created by our group. Most of us is from Kyiv University, named of Taras Shevchenko. And it's about two-level problems. The outer level is variational inequality. Here you can recall the concept. We search for X from convex closed set A, which satisfies this inequality 1. And the inner level is general formulation of equilibrium problem. Here you see marked as 3. You see this problem. Such problems include Nash equilibrium problems, or it can be also a variational inequality, and or some other problems which are described by such abstraction. Later you will see, we'll discuss examples. So we search for solution of variational inequality on the set which is described as solutions of equilibrium problem. So it's two-level.
Не, да я думаю, какие-то другие там проблемы может. Да, кивает, что другие проблемы.
Okay. Here we have example. What equilibrium problem can be a Nash equilibrium problem. In such case, we have this view of our convex set C, and function f has next view as sum. So main formulation. We are search for the solution of this variational inequality on set of solution of equilibrium problem. Or if we write it short, we can write it as 5. For example, you can look at this problem or imagine it as...
Типа докер-файлы только. Он этот Visual Studio для проектов ASP.NET билдит какой-то неполноценный докер-файл, если так это можно сказать.
Виключіть, будь
Он не
ласка,
до конца
мікрофони,
готов.
хто не доповідає.
І
Ви заважаєте.
А якщо хто адміністратор, може вимкнути, якщо видно,
The host muted you. Короче.
Thank you.
Зачем нужен был этот PowerShell?
Пане Головатенко, будь ласка, да, мікрофон виключіть. Дякую.
Сука, извините. В том числе для локального дебага, но так... Что происходит?
Excuse me.
Вы на конференции ATIT, вы это знаете?
Для локального дебага и еще этот скрипт под...
До свидания.
About local debug and other very interesting things. Okay, so let's try to continue. So we can view this problem as minimization problem of function f on solutions of on the set of solutions of variational inequality, and at the same time we are trying from the solutions of from the set of minimal values, we try to find values which are closest to point A. So it's an example. We can formulate this problem which is red here. We can formulate also as this problem. So it's like a search for the best solution from the set of solution of minimization problem. It can be viewed as such problem. Okay, so now closer to our result. If our function f from equilibrium problem and our sets satisfy these conditions, it can look that there are a lot of strange conditions, but these conditions are about monotonicity and closeness and convexiness, actually. Interesting one is A5. It's like it looks like kind of Lipschitz continuity for function f with constants a and b. And also important one is A7. Here a, it's an operator of outer problem and should be mu strongly monotone with constant mu. So, and if such conditions holds, we will prove correctness of the next algorithm. It looks like we do one step of kind of gradient algorithm about our variational inequality, and on each step of this outer algorithm, we need to solve auxiliary problem, solve minimization problem for our equilibrium problem. Here it looks like that it's not clear how to solve it, but actually we can notice that our function for minimization is strongly convex, so it has a single solution because strongly monotone, because this f is monotone and we have this extra addition here. But in such generic view, of course, it's not a full algorithm. Full algorithm we can create if we know something more about structure of this equilibrium problem. So here it's the same algorithm which is written step by step. We start from initial solution and we do this step. On inner step we solve this auxiliary problem, and one thing that can be noticed here that instead of choosing that lambda from classical conditions, it looks like conditions from Lipschitz continuity here, but we usually do not know these constants. So we created modified adaptive version of this algorithm where we can choose lambda without a priori this const. So we choose lambda using this procedure. It looks quite maybe scary, but actually we do not need to solve any auxiliary problem here as in some adaptive algorithms. We need simply to calculate our operators and norms. If our equilibrium problem can be stated as variational inequality, we can provide more simple version and of this algorithm. The first step is the same, and the inner step do not require us to solve auxiliary minimization problem. It's step of some extra gradient kind algorithm, such as Popov algorithm here, or it can be other algorithm. So this case is quite okay, I can't say it's simple, but we have no complex sub-problems here. And again, we do not need to know anything about Lipschitz constants of operators A or A1 or A2. step for choosing lambda is same. I can add that in practice here, this procedure, if you look at it, it always leads to non-increasing or decreasing lambda. And empirically, it's not always very effective. In numerical experiments, it's sometimes more effective to add step where we can try to increase our lambda if we can. We can increase it, check these conditions, and if it holds, we can try to do step with greater lambda, and it increases speed of calculation. And here the main theoretical results about convergence of this algorithm. We consider auxiliary problem. I can say in advance that we will not solve it. We do not need to solve it. We simply use it to prove convergence of the main algorithm. And for that problem, we prove such facts. And the main fact is that solution of this problem, which looks like a regularized problem, converges to the solution of our initial problem. And so our next steps is to solve, to show that xn and yn of our main algorithm, I mean here, this yn and xn, are converged to solution of this problem. So we show it with the next assumptions and quite classical assumptions for this alpha n. I can remind that alpha n is here. It's a constant in outer step. So if for alpha n we have these classical conditions, we can prove that that our solution from our algorithm xn converges to solution of this auxiliary problem from the previous slide. So to prove it, we have got such quite a scary inequalities, but it's simply complex transformations and no fundamental things here. So we can prove these inequalities, and from inequality from lemma 4, which shows some estimation for solution of our initial problem and solution of this our auxiliary problem. You can note that here we use actually Lipschitz constant mu, which is constant from the strong monotonicity of our operator, but they are used only in proof. They are not used in algorithm. So, and from these lemmas, we was able to prove the main theorem, which states as a result that our algorithm, our xn and our yn converges to a solution of our real problem, x. Results of the work and preliminary results was also published in some articles where we have all these transformations, I mean these proofs of these things. So again, the main result may be easier to see here. We have such algorithm for two-level problems, which can be considered as solution of variational inequality on solutions of another variational inequality, which has not single solution. And we prove that such algorithm works. Here, we also, I want to emphasize that in such case, we do not need extra calculation of operators to choose lambda for the next step, because all these values are already calculated during the step itself. Okay, so I think that's all. Thank you for your attention. If you have any questions,
Thank you for a very interesting report. Have you any questions?
I have one question.
Please.
Please say me, what's the conversion rate of your algorithm?
It's sublinear.
Is it your result or it is well known?
No, it's we are not investigated it here, but our group works on several such kind algorithms, and usually we have, in best case, linear, but in general case, it's less than linear.
Theoretically proved, yes?
Yes, but not by us, but for such kind of algorithm.
Thank you.
Thank you. Questions? No questions. Thank you for your very interesting report.
Thank you.
Okay, I want to invite to speak next our participant Andrew Bulashenko, Stepan Pilyatый, Елизавета Kalinichenko, Alexander Bulashenko, mathematical modeling of iris post sections for wave-guide filters, phase shifters, and polarizers. It's here.
Good morning, dear colleagues.
Good morning.
I'm Елизавета Kalinichenko, and today I'm presenting our presentation. Okay, can you see?
Yes, I can.
So, good morning, dear colleagues. My name is Елизавета Kalinichenko. I'm a student of National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. My presentation is about mathematical modeling of iris post sections for waveguide filters, phase shifters, and polarizers, which was developed by our work group. So nowadays, there are many new designs of narrow and wideband waveguide filters, phase shifters, and polarizers, which are used in different areas of science and technology. Waveguide filters are applied in high-power antenna feeds for satellite information systems, radars, and communication with space probes. Waveguide phase shifters are an essential part of phased array antennas for military radars. Polarizers are key elements of antenna systems which operate in dual orthogonal circular polarizations. The designs of polarizers in the form of phase shift sections based on thin symmetrical irises located on two opposite walls of a square waveguide, and they are investigated in many papers and widely applied. A polarizer is used to form linearly polarized waves in reflective antennas. Among the large numbers of different types of polarizers, the polarizer in a square waveguide based on irises is widely used due to its simple design and simple manufacturing process. It's relevant to suggest and develop new analytical techniques for the calculation of characteristics of polarizers based on square waveguide. With irises and posts, which require differential phase shifts and good matching performance in the operating frequency bands of telecommunication and radio engineering systems. The inner structure of a suggested square waveguide section is presented on this slide. The design of this section contains two identical posts and two identical irises. Each pair of antiphase posts is located symmetrically in the middle of two opposite walls of the square waveguide. The same walls of the waveguide contain both irises. Using the analysis of microwave devices based on the theory of wave scattering and transmission matrices, we developed the mathematical model of the irises and posts in a square waveguide. For the analysis, we apply a single wave approximation using the techniques of wave matrix theory. The general view of the equivalent circuits of a waveguide with 2 reactive irises and 2 reactive posts is given on the next slide. For the fundamental mode with vertical polarization, the equivalent circuit of a square waveguide section can be divided into 5 simple 2-port circuits. It's the first figure here. They include two 2-port circuits, which are equivalent to the capacitive irises, 1 circuit equivalent to the capacitive post, and 2 circuits of regular segments of transmission line. Each 2-port circuit is described by its own wave transmission matrix. The network shown as on the slide takes into account the thickness of the iris by using a P-shaped substitution equivalent circuit. Then the general wave transmission matrix of the waveguide section is determined as follows. This equation, where the elements of a general transfer matrix are under general wave matrix. For a capacitive iris, the reactive conductivities of the equivalent circuit are determined by the expressions on these slides. Relationship between wave transmission and scattering matrices is here. For the fundamental mode, propagation with horizontal polarization and the polarization, the equivalent circuit of a polarizer, can be divided into 3 simple 2-port circuits. They include 2 2-port circuits, which are equivalent to the capacitive irises, and 1 2-port circuit of a regular segment of transmission line. Each 2-port circuit is described by its own transmission matrix. Okay. In order to take into account the thickness of the irises, we use the T-shaped equivalent substitution circuit. Then the wave transmission matrix and its elements are determined on the slide. Relationship between wave transmission and scattering matrices is as follows. For an inductive iris, the reactive supports of an equivalent circuit are determined by the expression on this slide, where A is the size of the wider waveguide wall, W is the iris's thickness, and H is the iris's height. The polarizer of the antenna system determines its axial ratio and cross-polar discrimination. Here are some main formulas for our calculation. It's a general formula for the calculation of ESWR, the different phase shift between vertical and horizontal polarization, the expression of axial ratio, the expression of cross-polar discrimination, the distance between the irises, the variation of the value of the thickness height of the iris H, the height of the iris, and the cutoff frequency. Okay. Also, here and below, we present the results of the calculation using the suggested mathematical model of the waveguide section with 2 irises and 2 posts. The dimension of the wall of the square waveguide were chosen for obtaining of a single mode operation in frequency range from 7.7 to 8.5 gigahertz. Then the distance between the irises can be approximately estimated. This slide shows the differential phase shifts of the first developed waveguide section. I'm sorry. Yes, here are some dependencies of the 2 sections. of our mathematical model. From first figure, we see that the phase shift approaches 45 degrees and varies from 42.8 to 47.2 degrees. And at the 8.09 gigahertz, the phase is exactly 45 gigahertz. Minimum differential phase shift is 42.8 degrees at 7.7 gigahertz. The maximum differential phase shift is 47.2 degree at 8.5 gigahertz. Second figure of the first section shows the dependence of VSWR on the frequency for vertical and horizontal polarization in the operating frequency range. Also, we see that VSWR for the vertical polarization increases the level of 1.22 at the frequency of 7.7 and up to 1.42 at the frequency of 8.5 gigahertz. Also, we see that VSWR for the horizontal polarization decreases the level of 1.34 at the frequency of 7.7 GHz and up to 1 at the frequency of 8.11 GHz and increases to the level of 1.46 at the frequency of 8.5 GHz. First figure of the second waveguide section shows the phase shift between fundamental modes with a vertical and horizontal polarization in the operating frequency range, which varies from 7.7 to 8.5 GHz. We also see that the phase shift approaches 13 degrees and varies from 28.9 degrees to 31.1 degrees. At 8.1 gigahertz, the phase shift is exactly 30 degrees. The minimum differential phase is 28.9 degrees at 7.7 gigahertz. And the maximum differential phase shift is 31.1 at 8.5 gigahertz. The second figure of the second waveguide section shows the dependencies of a VSWR for vertical and horizontal polarization in the operating the same frequency range. And we also see that VSWR for the vertical polarization increases to the level of 1.06 in the frequency of 7.7 gigahertz and up to 1.31 at the frequency of 8.5 gigahertz. Consequently, in this operating frequency range, optimized sections of a square waveguide with 2 irises and 2 posts provide the following characteristics. VSWR for both polarization is less than 1.4. The differential phase shift is within the range 45 degree is plus minus 2.2 degrees, and for 13 degrees is give or take 0.7 degrees. The numerical simulation and optimization of developed section of square waveguides with 2 posts and 2 irises were performed by using the finite integration technique in the frequency domain. The obtained numerical results are presented in this section below, and the figures on this slide present the dependencies of differential phase shift and VSWR on the frequency for the developed first section of the waveguides of the square waveguide with posts and irises. First figure shows that within the operating frequency range, the differential phase shift is the optimized section of our polarizer with 2 antiphase posts and 2 irises, varies from 43.5 degrees to 45.6 degrees. And the maximum deviation of the differential phase shift for the developed waveguide section is 1.75 degrees. The second figure shows that VSWR for the of the first developed square waveguide section with 2 posts and 2 irises for both fundamental modes is less than 1.4 in the whole operating frequency range. Plots presented on this slide shows us the dependence of the differential phase shift and VSWR on the frequency. For the developed second section of the square waveguide with posts and irises, the first figure shows that within the operating frequency range of from 7.7 to 8.5 GHz, the differential phase shift of the optimized waveguide section with 2 posts and 2 irises varies from 9.85 degrees to 29.48 degrees. The maximum deviation of the differential phase shift of the developed waveguide section is 0.42 degrees. Second figure shows that VSWR of the second waveguide section with 2 posts and 2 irises for both fundamental modes is less than 1.37 in the whole operating frequency band. This slide shows us 2 tables which have sizes and characteristics of optimized square waveguide sections. Our first table presents the sizes of both 13 and 45 degrees square waveguide differential phase shift sections with 2 irises and 2 posts, which were optimized for the operating frequency band, X-band, which varies from 7.7 to 8.5 GHz. The second table presents the characteristic of the developed square waveguide section with 2 irises and 2 posts, which were optimized for our frequency band, which varies from 7.7 to 8.5 GHz. As we can see in this table, the section of the waveguide polarizers with 2 irises and 2 posts provide good matching because their maximum level of VSWR is lower than 1.4. Conclusions. New mathematical model of this section of our square waveguide containing 2 posts and 2 irises has been created in the research, and the developed mathematical model was used for the analysis, development, and optimization of characteristics of 2 waveguide sections with differential phase shift 30 and 45 degrees. Developed optimized waveguide section provide VSWR less than 1.4 for both polarization, and differential phase shift varies within the ranges for 30 degrees is take or give 0.7 degree, and for 45 degrees is plus minus 1.75 degrees. The results obtained by the suggested mathematical model can be used for initial approximate estimation and optimization of characteristics of the polarizers based on 2 or 3 sections of the developed types. Our future investigation will be focused on creating mathematical models with a larger number of irises and posts to provide better performance for waveguide section and microwave devices based on them. Developed to enable iris post sections can be widely used to create new waveguide filters, phase shifters, and polarizers for various applications. Thanks for your attention.
Thank you for a very interesting report. Have you any questions? No questions. Okay.
Thank you.
Thank you. Good. I have one question. Mr. Mikhailo Polishuk is here. Mikhailo Polishuk. Not here. Good. Okay, I would invite to speak.
Yes, Mikhail Polishuk, yes.
Yes, okay. I invite to speak Mikhailo Polishuk, Mikhailo Tkach, with report Information Technology for recognition of semi-precious minerals.
Please.
Yes.
Yes, here. We bring to you attention report. See ekran. See display. Thank you. Thank you. Technical problem.
Okay.
Technical problems. Yes, Doctor?
Yes, I see your presentation. It's okay.
Beautiful. Yes, they bring to your attention a report, information technology of the recording semi-precious minerals. The present research is devoted to solving the problems interfered with semi-precious minerals used in general problems. This report proposes a new information method of recording and comparing the volume of mineral to sort them. Important is the accessory of sorting minerals necessary to minimize the loss of the valuable rate material to production of general. According to the process technology, the total volumes mineral supplement for sorting is determined, and the volume is compared with one on several the volumes generally produced. The proposed technical solution increasing the accuracy of sorted mineral and reducing amount of the waste dying for the mechanical processing of semi-precious minerals. The proposed method contributed to the rational use of natural resource. The technology is designed for the recording semi-precious minerals based on the digital order they make generally from semi-precious, amber, diamond, emeralds, garnets, topaz, rock crystal. Mineral volume recording method. Argument on the CDD matrix in the planes on the XYZ coordinate system. 3 volt. Determine the possible number on the balls on the mineral objector calculated the minimized amount of fasting. Minimum brutto netto and maximum volume netto. Circuit matching on the semi-precious minerals. Please. Automatic installation of digital sorting. Numeral analysis on the mineral sorting. Graphs on the influence on the geometric parameters of minerals in the volumes. Dependency function. Excuse me. Dependency function. Volume, length, function, length, width, height. Please function. Competitive advances. A fundamental new method of the sorting White prion orientation on mineral stones. Regards is the tip. High sorting accuracy. up to minerals. Second, minimization of the waste semi-precious minerals and precious stones up to in the manufacture, the general and semi process. Patents UR method of storing small minerals and device for its interpretation. A method is of making bells from minerals. Study authors Mikhail Polishuk, Mikhail Tkach, National Technical Institute. Thank you for attention.
Thank you for a very interesting report. Have you any questions?
Please.
No questions. Okay.
It is not my line. It is not my line.
Okay, good. Thank you.
It is not mine. Thank you.
Good. I want to invite to speak next our colleague Володимир Мирненко, Сергій Кітик, Олександр Глоба, Олексій Чорнобривченко, Дмитро Резнік і Михайло Левченко. Report Semi-Markov mathematical model of complex radioelectronic system operation process with limited possibilities of internal control means. Anybody is here? No. Okay, maybe later. Next report today is Степан Пілятий, Андрій Булашенко, Ганна Кушнір, Олександр Булашенко. New tunable iris post square waveguide polarizers for satellite information systems.
Good morning. Are you hear me?
Okay. Good morning.
Okay. I share my. Do you see it?
Yes, I see.
Okay, let's start. Okay. Okay. Good afternoon, dear colleagues. My name is Hanna Kushnir. I am a student on National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. My presentation is about new tunable iris post square waveguide polarizers for satellite information systems. Now many new designs of waveguide polarizers became widespread in many radio engineering and telecommunication applications. The main function of waveguide polarizers is the transformation of electromagnetic waves with circular polarizations into linearly polarized waves and vice versa. A decomposition of fundamental electromagnetic modes can be realized by means of various transversal or longitudinal discontinuities in circular or square waveguides. Recently, satellite systems began to use antennas with a large number of bands. In such systems, it is convenient to use iris-based polarizers due to the wide frequency band and the ability to operate in multiple bands simultaneously. The development of designs of waveguide polarizers, which provide wide operating frequency bands and fine-tuning of their characteristics, is an important relevant problem for modern areas of telecommunications and radio engineering. Developed in this paper, new tunable waveguide polarizers allow to obtain the required performance. Therefore, the combination of irises and posts is in one structure allows to create new waveguide polarizers which simultaneously provide good performance in wide fractional bandwidths and the possibility of fine-tuning after manufacturing of the device. Let us consider a simple waveguide section, which consists of 2 irises and 2 antiphase posts located in a square waveguide. Its inner structure is demonstrated in figure 1. Both antiphase posts and both irises of the square waveguide section are identical in order to avoid the extraction of undesirable higher order modes. Each of antiphase posts is located symmetrically in the middle of 2 opposite walls of the square waveguide section. Based on the analysis of waveguide devices by the wave scattering and transmission matrices, we will create a mathematical model of the irises and posts in a square waveguide, which contains several rectangles of capacitive and inductive types. On the left side of this slide, we can see the calculations of parameters that we need for our analysis. These parameters we used in our matrix, which we wrote on the right side. In the case of vertical polarization, the equivalent circuit of a polarizer can be divided into 5 simple 2-port circuits. They include 2-port circuits, which are equivalent to the capacitive irises, 1 circuit equivalent to the capacitive posts, and 2 circuits of regular segments of transmission line. Each 2-port circuit is described by a wave transmission matrix for the waveguide model with 2 identical capacitive irises and posts. The polarizer of the antenna system determines its main polarization electromagnetic characteristics, such as differential phase shift, axial ratio, and cross-polar discrimination. Therefore, these characteristics will be determined using the developed models for the square waveguide polarizer based on iris post sections. Shows the inner structure of a developed polarizer based on a square waveguide with 4 posts and 4 irises. The polarizer is filled by the air, and the irises are manufactured by the milling from a metal block. The inner material and the material of irises were simulated as a vacuum and perfect electric conductor, respectively. The developed polarizer can be considered as a series connection of 2 waveguide sections with 45 degrees differential phase shift per each. The equivalent model of a polarizer with 2 iris post sections is presented in figure B. And table 1 presents the sizes of the polarizer designs, which were optimized of the operating X band 7.7 to 8.5 gigahertz. This slide shows phase and measure characteristics of a numerical simulation for the developed square waveguide polarizer with 4 irises and 4 posts. Figure A shows dependencies of VSWR on frequency, and figure B describes differential phase shift on frequency too. As we can see, within the operating frequency range 7.7 to 8.5 gigahertz, the optimized polarizer based on a square waveguide with 4 posts and 4 irises provides VSWR less than 1.23 for fundamental modes of horizontal and vertical polarizations. The differential phase shift introduced by the polarizer lies within the range 90 degrees plus minus 3.5 degrees. Okay. This slide shows the polarization characteristics of a numerical simulation for the developed square waveguide polarizer with 4 irises and 4 posts. Figure A describes the actual ratio with frequency, and figure B shows the dependence of XPD on frequency. Figure A shows that within the operating frequency range 7.7 to 8.5 gigahertz, the actual ratio of a polarizer with 4 irises and 4 posts less than 0.5 decibel. And figure B demonstrates that corresponding cross-polar discrimination is higher than 31 decibel. Okay. In order to improve the matching of the developed polarizer, we decided to add the additional iris post waveguide section and divide the differential phase shift between 3 sections. In this case, each section introduced 30 degrees differential phase shift instead of 45 degrees of the previous design. As a result, we obtained structure with 6 irises and 6 antiphase posts. This based on 3 identical iris post sections is demonstrated in figure A. The developed square waveguide polarizer can be considered as a series connection of 3 waveguide sections with 30 degrees differential phase shift per each. The equivalent model of this polarizer with 3 iris post sections is presented in figure B. And the table 2 presents the sizes of a square waveguide polarizer designs with 3 sections with which were optimized for the operating X-band. This slide shows the phase and matching characteristics of a numerical simulation for the developed square waveguide polarizer with 6 irises and 6 posts. Figure A shows dependencies of VSWR on frequency, and figure B describes differential phase shift on frequency. Within the operating frequency range 7.7 to 8.5 gigahertz, the optimized polarizer based on a square waveguide with 6 interface posts and 6 irises provides VSWR less than 1.17 for fundamental modes of horizontal and vertical polarization. The differential phase shift introduced by the developed polarizer lies within the range 90 degrees plus minus 2.2 degrees. This slide shows the polarization characteristics of a numerical simulation for the developed square waveguide polarizer with 6 irises and 6 posts. Figure A describes the actual ratio with the frequency, and figure B shows the dependence of XPD on frequency. Figure A demonstrates that within the frequency range of 7.7 to 8.5 gigahertz, the actual ratio of a polarizer with 2 irises is less than 0.34 decibel. Figure B shows the corresponding cross-polar discrimination is higher than 34 decibel. Okay. As a conclusion, we can say that 2 new designs of tunable square waveguide polarizers with irises and posts were optimized for the operating X-band 7.7 to 8.5 gigahertz. The first polarizer consists of 2 waveguide sections with differential phase shift 45 degrees, and the second one consists of 3 waveguide sections with differential phase shift 30 degrees. found their VSWR, differential phase, actual ratio, and cross-polar discrimination. Developed new tunable polarizers based on square waveguide sections with irises and active phase posts, widely applied model meteorological and military radars, satellite information, and telecommunication systems. Thank you for your attention.
Thank you for your report. Have you any questions? No questions. No questions. Yes. Good. I invite to speak next our participant Anton Korotinsky, Alexei Zhuchenko, development of a classifier for the system of automatic document processing with limited sampling.
Hello to all.
Yes, please.
Can you hear me? Yeah. Can you see?
Yes, I see.
Currently, the activities of any institution are impossible without the organization of document flow. The need to obtain documents, verify, enter information into the relevant database take a lot of time of operator of a relevant system, and it is necessary to take into account the human factor, namely the error of operators. Replacing the stages of manual processing with software will reduce the processing time of documents and remove the impact of human factor of accuracy of work. It follows that the solution of the problem of developing an automation document processing system is quite relevant in the current type of widely spread introduction of electronic document management. The paper considers to the solution of the only one of component of the system of automation recognition of scan and photo documents, namely the classifier of image obtained after processing the documents by segmentator. The classifier is proposed to be performed on the basis of artificial neural networks, which solves the classic problem of pattern and image recognition. To solve this problem, it's necessary to analyze the initial data, determine the architecture of neural network, expand the initial data set, and train the neural network. The main idea is that to develop this system, such system is to needed a lot of time to prepare the initial data. We decided that the printed and handwritten words of numbers can be defined as one class, and when the learning the neural network for them will should form similar patterns. Therefore, the number of classes for handwritten and printed verbal grades will be 12, and the same numbers for handwritten and printed numbers. As fragment of the document gets after segmentation, it can be a situation when the format segment will be empty. Therefore, a separate class must be defined for an empty field. In accordance to all, 25 classes were previously identified to solve the problem of classification. Preliminary analysis of the data shows that are two main problems: the lack of members of some classes and the uniqueness of members between all classes. It is clear that learning a neural network without members of some classes does not make sense. This problem can be solved in different ways. For example, expanding the samples due to existing data sets, such as amnesty in this situation, which is not a universal solution for similar problems. Expanded the sample by processing more documents, or artificial creating class members. Since the problem is solved under the condition of limited materials for learning neural network, we'll assume that existing data sets not expand, the initial samples does not exist, so choose later options. It is known that the best way to obtain a model without retraining that is increase the amount of training data. The model trained on a large amount of data will have great generalization. In addition, large samples allow you to increase the depth of the neural network. On the other hand, the limited size of training sample minimizes the parameter for training, therefore, and the depth of network. Due to limited data, it is proposed to use the principle of minimization as the structure of the neural network to develop a neural network classification. Training the autoencoder for reproduction of scanned photo of the estimations received after augmentation does not cause problem of retraining of data restriction. After retraining autoencoder, we will get the part of our network, the part of our classifier. By freezing this layer of neural network, which were previously trained in the synthesis of the autoencoder, and conduction additional training of full connected layer, we get ready-made neural network classifier with following accuracy parameters. And conclusion. It's all what I want to say.
It's all, yes?
Yes.
Yes, thank you very much for your very interesting report. Have you any questions? No questions. Okay, thank you. Next, I want invite to speak Степан Пілятий, Андрій Булашенко, Євгеній Гергель, Олександр Булашенко with report Fdtd and FEM simulation of microwave waveguide polarizers.
Okay. Just a moment.
Yes.
Can you see my screen?
Yes. I can see.
Okay, let's start. Good afternoon, dear colleagues. My name is Yevgeny Herrer. I am a student of National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. My presentation is about Fdtd and FEM simulation of microwave waveguide polarizers, phase shifter and polarizers, which was developed by our work group. In this research presents results of comparison of modern effective numerical technicals for the calculation of microwave device. Nowadays, finite difference time domain method and finite elements method are the most frequently used numerical technicals, which are applied for the simulation of electromagnetic fields in various antennas, and bounded structured polarizer and is an essential element of modern satellite antenna systems, which apply signals with the signal or dual orthogonal circle polarization of electromagnetic waves. We have compared finite definite time domain technical and the finite elements method in the case of calculation of polarization and matching characteristics of microwave waveguide Irish polarizers. The design of development polarizer based on a square waveguide with 5 symmetrical irises is present in this slide. Waveguide polarizers is an essential element of modern satellite antenna systems, which apply signals with single or dual orthogonal circle polarizations of electromagnetic waves. All design of waveguide polarizers can be divided into 3 main groups. Today, there are many scientific articles and conference papers decided to the development and optimization of Irish polarizers, septum polarizers and post polarizers. A main engineering problem during the development of polarizers is very high sensitivity of their phase and polarization characteristics to the increasing of determination of the optimal structure dimensions and of the manufacturing of polarizer design. Okay. Polarization is characterized by several important parameters: actual rate and cross-polar discrimination, OXPD. The formulas for which are shown on this slide, where A and B stand for the magnitudes of electric fields orientated along X and Y axes, respectively. And delta phi is phase difference. So, during the numerical optimization of development square waveguide Irish polarizer, the actual rate and the XPD at the polarizer's output were simultaneously analyzed along with the differential phase shift and VSWR for fundamental electromagnetic modes of both polarization. The goal function of the optimization are VSWR for the fundamental models of both linear polarizations less than 1.15 and XPD higher than 32 decibel in the operating Q-band from 10.7 to 12.8 gigahertz. As one can see in figure A, in the operating Q-band, the maximum level of VSWR for fundamental models of both horizontal and vertical polarizations is approximately 1.30, which fully statistics and requirements. Figure B shows that the differential phase shift of the optimized square waveguide Irish polarizer varies from 87.5 degrees to 92.5 degrees. Let us consider polarization characteristics of the development waveguide Irish polarizer. Actual rate of the polarizer was calculated using the FEM simulation results. In figure A, it is seen that the actual rate of the optimized polarizer is less than 0.4 decibel in the operating frequency band, as one can observe in figure B, in the wall operating XPD or the polarizer in higher than 32 decibel. Figure A, B, and C present the results of numerical calculation of the phase and polarization characteristics Irish polarizer using FEM in the frequency domain. As we observe in figure A, B, and C, numerical results converge very fast with the increasement of the number of tetrahedral mesh cells from 20,000 to 100,000. The further increasement of the number of mesh cells from 100,000 to 200,000 leads to much slower alteration of the phase and the polarization characteristics. Therefore, then 100,000 tetrahedral mesh cells per structure volume must be used if the calculation of the polarizer's actual rate and XPD is performed by FEM in the frequency domain with the required accuracy of half decibel. Results of numerical simulation using FEM were obtained for numerical of tetrahedral mesh cells from 20,000 to 200,000. Step of mesh increasement was 20,000 mesh cells. The calculated electromagnetic characteristics of the square waveguide Irish polarizer as function of the number of mesh cells and the computation time are shown in table on this slide. Figure B and C, A, B, and C presents the results of numerical calculation of the phase and polarization characteristics of the development square waveguide Irish polarizer using Fdtd method. It is seen in figure A, B, and C that the numerical results converge very fast with the increasement of the number of hexagonal mesh cells from 100,000 to 800,000. Further increasement of the number of hexagonal mesh cells from 800,000 to 1,500,000 leads to much slower alteration of the phase and polarization characteristics. Therefore, more than 800,000 hexagonal mesh cells per structure volume must be used if the calculation of the polarizer's actual rate and XPD is performed by Fdtd methods with the required accuracy of half decibel. On this slide, the results of numerical simulation using Fdtd were obtained for number of hexagonal mesh cells from 100,000 to 1,500,000. The step of mesh increasement was 100,000 mesh cells. The calculated by Fdtd electromagnetic characteristics of the square waveguide Irish polarizer as function of the number of hexagonal mesh cells and computation time are shown in table on this slide. Finally, let us compare the numerical performance of FEM and Fdtd method for the calculation of characteristics of the square waveguide Irish polarizer. In table, we see that for the same accuracy of calculation of the phase and polarization characteristics of microwave devices, the computation time required by FEM in the frequency domain is more than 2 times less than the time required by Fdtd method. Besides, the corresponding number of tetrahedral mesh cells in FEM is 10 times less than the number of hexagonal mesh cells in Fdtd method. Conclusions. It has been found that more than 100 tetrahedral mesh cells per structure volume must be used if the calculation of the polarizer's actual rate and XPD performed by FEM in the frequency domain with the required accuracy of half decibel. More than 800,000 hexagonal mesh cells per structure volume must be applied if the calculation of the actual rate and XPD is performed by Fdtd method with the required accuracy of half decibel. The computation time required by FEM in the frequency domain is more than 2 times less than the same time required by Fdtd method. Besides, the corresponding number of tetrahedral mesh cells in FEM is 10 times less than the number of hexagonal mesh cells in Fdtd method. Therefore, FEM in the frequency domain which applies tetrahedral mesh is more effective than the Fdtd method for the calculation of phase and polarization characteristics of modern waveguide polarizers and other microwave devices for various applications. Thank you for your attention.
Thank you very much for your very interesting report. Have you any questions? Maybe questions for the report? No questions. Good. Thank you. And I want to invite to next report Alexander Stryuk, Yuri Kondratenko, Evgen Sidenko, Alla Vorobyova, Generative Adversarial Neural Network for Creating Photorealistic Images.
Hello, dear colleagues and participants of IEEE ATIT 2020. My name is Alexander Stryuk. I'm a PhD student at Petro-Mohyla Black Sea National University, and I would like to present our paper on the following topic: a generative adversarial neural network for creating photorealistic images, by Alexander Stryuk, PhD student, Yuri Kondratenko, Doctor of Science, Professor, Evgen Sidenko, PhD, Associate Professor, Alla Vorobyova, PhD, Associate Professor. On behalf of all co-authors of the paper, I will be the speaker. Let me please share my screen.
Yes, it is.
Can you please confirm if the slide of my presentation is visible at the moment?
Yes, it's visible. I see.
Okay, thank you. So with your permission, I'll start.
Okay, please.
Generative adversarial neural network for creating photorealistic images. Generative adversarial network, GAN, is the implementation of an AI algorithm class that is used in unsupervised learning that represents the architecture of two artificial neural networks that compete with each other in a zero-sum game. The concept was proposed and developed by an American AI research scientist, Ian Goodfellow, in 2014. This methodology made it possible to create quality graphic samples close to photographs or even identical to them in the spectrum of properties, which consist of highly realistic elements. GAN works according to the following principle. The first network, the generator, creates samples, candidates, and the second, the discriminator, evaluates them, trying to distinguish false from truth. The generative network tries to form a new sample by combining primary patterns using latent space variables. The discriminator network learns to distinguish between real and faked samples, and the analysis results are fed to an input of the generative network so that it can choose an even better set of latent parameters. The discriminator network could no longer distinguish real samples from counterfeit ones. In both networks, the backpropagation method is used, which ensures the generation of better and better samples by the generator. And the discriminator, in turn, evaluates the synthesized images more efficiently. Usually, the generator is designed as a deconvolutional neural network, and the discriminator is designed as convolutional network. GAN can be used to implement various tasks to create photorealistic images that visualize visualize a new design of any object or industrial products, such as telescopes, robots, rocket bodies, scenes in video games, etc., to improve astronomical images and simulate gravitational lensing for dark matter exploration. The methodology was successfully applied to model the dark matter distribution in a specific direction in space. The model also allowed to predict further concomitant gravitational lensing. Generative adversarial neural networks have been successfully tested as an effective and accurate method for representation of high-energy jet formation and emulation of electromagnetic calorimeter showers. This technique has showcased the high potential of accelerating the simulation procedure and its accuracy during CERN experiments. Zhavrenkov et al. Described the process of developing new molecules using artificial intelligence and GAN that lasted only 21 days. The molecules have been successfully tested in mice. Experimental testing has shown the ability of GANs to accelerate drug discovery. It was reported that GANs are able to successfully design novel molecules for different inflammation, fibrosis, and cancer-inducing protein targets. The combined techniques of machine learning and GAN have confirmed their applied effectiveness in discovering new stable materials and predicting their crystal structure. The mathematical description of GAN can be represented as a variation of the Minimax two-player game, where G is the generator network, D is the discriminator network, X is a sample of real data, Z is noise, PZ of Z is a prior on input noise variables, P data of X is a prior on input real data variables, E is a prediction or expectation, D of X is the probability that X actually is from the data rather than from the generator, V of D, G is the value function of discriminator and generator in the two-player Minimax game. The proposed framework and its mathematical proof demonstrated the effectiveness of the GAN method in estimating generative models through an adversarial process, in which two of these models were trained simultaneously. A generator network G captures the data distribution, and a discriminator D estimates the probability that a generated example came from the training data rather than the generator network. The training task for the generator network is to maximize the probability of the discriminator making a mistake. Within the framework of this paper, Python 3.7.6, TensorFlow, and Keras libraries were used for the practical implementation and testing of GAN. For stochastic optimization, the ADAM algorithm was applied. This method allows us to apply a stochastic gradient descent technique. This algorithm is based on adaptive estimates of low-order moments and designed for first-order gradient-based optimization of stochastic objective functions. This algorithm is built into the network architecture for performing stochastic optimization in both models, in the generator and discriminator. The main experimental expectation is the optimization of the learning rate and the momentum of the created neural network. The MNIST database, the abbreviation stands for Modified National Institute of Standards and Technology database, was used as a training data set, which is a set of handwritten digits from 0 to 9. Sample images from MNIST test data set are presented in Figure 1. The MNIST database consists of 60,000 training graphical samples and 10,000 testing samples. For a full cycle of sample generation, 400 iteration cycles, epochs, were performed. Let's examine the graphic samples obtained during the experiment. The symbols are barely visible, their borders and outlines are indistinct. There is a lot of noise and defective artifacts around. However, even after the first training epoch, the model was able to generate an image that vaguely reassembled digits. Please see Figure 2. After the 20th epoch, the generated images got a tangible structure and shape. The obtained samples are much more similar to digits than the results of the first epoch. providing the effectiveness of the chosen training and optimization algorithm. However, only a quarter of the samples can be considered as successful. Other samples do not have a clear shape, contain noise traces, or do not look like digits at all. See figure 3. The results of the 400th epoch indicate the success of the experiment, since the overwhelming majority of obtained symbols are similar to real digits. They are distinguished by a sufficient level of clarity, structure, shape, and there is no significant graphic noise. Figure 4. To obtain images of even higher quality, the experiment can be repeated with the same parameters, but increasing the number of epochs to 500 or even 1000. However, without further improvement and optimization, this will increase the duration of generating the final results. As a result, the generative adversarial neural network created new font examples of digits that look handwritten, and the obtained results can be considered as photorealistic graphic samples. Recent studies make it possible to positively assess the use of GANs, in particular for creating musical media components and synthesizing human speech. Today's scientific and applied efforts in the field of GANs are aimed at studying and researching the fundamental features of building and choosing models, the dynamics of learning, the characteristics of data representation relative to the features of the architecture. Conclusions. The theoretical and experimental research, along with the reviewed related papers, confirm the effectiveness of GANs not only in creating graphical prototypes, but also in applying this algorithmic architecture to problems of a wide range and different categories of complexity, from novel crystal structures to new molecules that help cure diseases. Combined with multimodal and multitasking approaches, GANs can effectively function as a component of a multi-agent integrated artificial intelligence system. The main focus should be directed to studying the technology limits and defining the control problem along with its effective solution. Thank you very much for your attention. Should you have any questions, please feel free to ask. Thank you.
Thank you very much for your report. Please, questions?
Hi, thanks a lot for your presentation. Have you tried to use another data set? Because in my opinion, this data set is hardly can be described as photorealistic one. So in my opinion, when I read your article name, I thought that you was some kind of nature landscapes or something like this. So have you tried something like this?
Thank you very much for the question. Yeah, we've considered another data sets, and actually we tried to test it on the CFAR10 data set, which contains graphic samples of different nature objects such as birds. But these data sets require more characteristics of the hardware. So not to overload the GPU, we decided to take this one, MNIST, as the most simplest one in terms of requirements to the hardware.
Okay, thanks. And the another one, how do you select the initial, let's say in your case, symbols for a GAN to work on them? How do you like this first initial images of these digits? How do you select them?
If I understand the question correctly, we just fed the data set to generator and to discriminator simultaneously, and after each iteration, the discriminator generated the first batch of images, then discriminator evaluated them, and through the backpropagation algorithm, the results were reiterated to the input of the generator. And this was the main flow of the experiment.
Thanks a lot.
Thank you.
Thank you. Have you any questions? Okay, no questions. Thank you for your report.
Thank you very much.
I will be invited to speak next our participant Vitaly Vrublevsky, Alexander Marchenko, paraphrase identification using dependency tree and word embeddings.
Hi, dear colleagues. Thanks a lot for having us here. My name is Vitaly Vrublevsky. I'm a PhD student in Taras Shevchenko Kyiv National University, and I'm going to present on behalf of also Alexander Marchenko our article, or like thesis, paraphrase identification using dependency tree and word embeddings. Hopefully you can see my screen. Can you confirm this? Yeah. Okay,
Yes.
great. Let's start. We are working on a global task, which is capturing sentence semantic meaning. The main two problems that falls into this, it's sentence similarity and paraphrase identification. Let's formulate this problem. What is paraphrase identification? This is a classic classification problem. The system gets two sentences and needs to decide whether they have the same meaning, they are paraphrases or not. Similar problem is semantic similarity. In this case, the system needs to estimate the similarity degree between two sentences. In this paper, we focus only on paraphrase identification to start with. Here is examples of paraphrases. For example, Ambrose accused his brother, whom he called the witness, of deliberately distorting his evidence. Another one, referring to him as only the witness, Ambrose accused his brother of deliberately distorting his evidence. This is rather simple examples of paraphrases because, as we can see, both sentences share a lot of similar words, and just word order could be a little bit different. But there are much harder one when some words interchangeable with their synonyms or something like this. Idea. So what is the novelty of our approach? We want to combine word embeddings and dependency tree. We want to use dependency tree to decompose the sentences into small phrases or small batches or bag of words. Then we use normalized numbers of matches between the two sentences as in features. I will describe the features in the following slides. In order to represent word semantics, we are going to use word embeddings. General purpose one, they are treated nowadays as a basic foundation for modern natural language processing tasks, and we are going to use them because of this. In order to compare words, we will use just simple cosine similarity, cosine distance as word similarity. Features. In order to tackle this task, we created a couple of our own features, plus we used a few general ones. First of them is Hungarian nodes match feature. What it is? First of all, we compute cosine similarity between each words in both sentences. Then we build cost table based on word similarity. What does it mean? What does it this cost table means? It's we pair words from first sentence with words from another one, and we will try to find matches from words from one sentence with words from another one. The Hungarian algorithm is trying to solve the linear sum assignment problem. So after that, we will have all words matched, except in cases when sentences do not share the same amount of words, then we will have some words that is left over. After that, after this match, we apply some threshold to filter only good quality matches. And then after this, we count these good quality matches and use this as an important feature. The next one is Graft edit distance based on the features that I described previously. First of all, we reuse Hungarian nodes match. So we reuse a match between words that were done in previous step. Then we apply graph edit distance algorithm for graphs that for dependency trees graphs based on the nodes match that we found already, and use this GED cost as an important feature. What is this graph at a distance algorithm? We used algorithm proposed by Ryzen et al. To compute this, and it is also based on Hungarian algorithm to compute the minimal cost. What kind of ATITs are available? It's a substitution, it's insertion, and it's change of node. Okay, let's go to the next one. Dependency tree paths feature. In order to compute this feature, we traverse the dependency tree from the root to the leaves and build different paths along the way. For all paths in the set, we compute aggregated embeddings using word embeddings in the path. With path embeddings, we can compare paths from the first sentence with paths from the second one. We're again going to use similarity threshold and count only good quality matches as a feature. In order to normalize this feature, we use number of all paths in both sentences. Next one is similar one, but we are not going to use paths, but we are going to use subgraphs. So we build all subgraphs with fixed depth from the dependency tree of first sentence as a second one. For all subgraphs, then we compute aggregated embeddings using word embeddings in this subgraph. With subgraph embeddings, we can again compare some graphs from the first sentence with subgraph from the second one. And the similarity threshold is applied again, and we filter out only and left only with good quality matches and use this as a feature. Next one is dependency tree subgraph feature with IDF feature. We use the same approach as the previous one, but start to use IDF as the base while creating word embeddings, while creating embedding for subgraph. Other features, this is kind of general well-known features that is used for these tasks. It's sentence length features, it's n-gram overlap, it's dependency overlap, which is simply we try to compare dependency tree edges. It's syntactic n-gram overlap. The main difference between syntactic n-gram and the ordinary one is in elements that are considered as neighbors. With simple n-graph overlap, we use just simple word order that is in the sentence. But with syntactic one, we use dependency tree and treat words as connected one if they're connected in dependency tree. And Bleu score, this is a score that is widely used for machine translation tasks, which is based also on n-grams, but their geometrical mean. The dataset. We used the Microsoft Research Paraphrase dataset corpus and ESRP. This corpus consists of around 6,000 pairs of sentences, which have been extracted from news sources on the web, along with human annotations indicating whether each pair captures a paraphrase or like semantic equivalence relationship. Distribution of true paraphrases in both the training set and testing set are almost equal. This is good for us because we don't need to solve the problem of balancing the data. This corpus was widely used for this task, so we are going to compare our results with state-of-the-art results and see the difference, see whether we have some improvements or not. Models. For our experiments, we choose a set of classical models like SVM, logistic regression, decision tree, random forest, and that are available in Python library scikit-learn. Also, for word embeddings, we are using pre-trained statistical model for English language developed by Spicy for dependency tree parsing and word embeddings. It is trained for using convolutional neural network on onto nodes. We do not train it, we take it as it is and use it in our software. In order to evaluate how different feature performs, we run a few tests with different classifiers for each feature sets that we created. The results for those tests are available in the following table. As you can see here it's only 3 features, the next one in the next slide. So from this set, tree dependency path gives us the best F1 score. Let's go to the next slide. Here we see that dependency tree subgraph gives the best F1 score. And overall, our system with all features give accuracy 75.4% and F1 score as 83.6%. Let's compare our results with current state of the art, and let's see what the difference is. As you can see, current state of the art has around 85.9% for F1 score. We have 83. So our system do not outperform the current state of the art, but it's important to mention that it beats quite a lot of other systems that were developed. And in those systems that we are seeing here there are one that is using a simple vector-based similarity, for example, this Malajevis et al., and we beat it. Plus, we wanted to prove the concept that dependency vectors with word embeddings can be used effectively for this task. We plan to further work on this task and probably try to use some graph neural networks or something similar and further improve performance of our model. Thanks a lot for your attention. If you have any questions, I will be welcome to answer them.
Thank you for your report. Questions, please.
Can I ask a question? Thank you for your really interesting report. Of course, my research is really very close to yours. Firstly, I'd like to ask you if this approach can be applied for other non-English languages. Because as far as I know, dependency tree cannot be built for languages like Ukrainian or Russians. Thank you.
Let's say that the main features, like what dependency tree give us, it give us relations between words like structure. I think that if we can, for example, in our example, we use dependency tree, but we can use some kind of different grammatical parse tree or something like this. And I think if we can try to build from some simple sentence some graph structure, we can reuse the same approach and the same algorithm.
So as I understand, we can also effectively use some phrases extraction mechanism, for instance, like in Stanford Core NLP, in order to extract some connections between words in order to build this graph. And also, I would like to ask you if you consider the usage of coreferent pairs detection, because maybe the detection of coreferent pairs, like an FRS search, maybe will help you to detect the similarity of the sentence, because these objects will be exchangeable.
Thanks a lot. It's a great question. Like, we are aware of these important features, but we wanted to stick mostly to the, let's say, graph-based features, but we are planning to explore it in the further work.
Thank you for your answers. Thank you for your report.
Thanks.
Thank you. More questions? No questions. Thank you for your very interesting report. Thank you very much. I want to invite to speak next our participant, Roman Mikolaychuk, Vladislav Lavrinovich, Anna Mikolaychuk, Tetiana Timoshenko, and Irina Somik-Ponomarenko.
Thank you very much for this possibility. So let me have some time to can you see my screen?
Yes, I see.
Can you see my presentation? Yep.
Yes.
Okay, it's quite. Is that good?
Yes.
Okay. So, sorry, this is the beginning slide. Wait a moment, please. Okay, so dear participants, I try to introduce our work, image segmentation and loss detection for conservation and restoration of old paintings. This is the instance of the cooperation of 3 Ukrainian universities, such as Taras Shevchenko National University of Kyiv, National Academy of Visual Arts and Architecture, also Kyiv, and State University of Telecommunication, all 3 from Kyiv. The problem of which we try to solving was the evaluate of the old painting losses during the restoration conservation processes to distinguish the cost of these works, to distinguish the state of the painting. We need to calculate percent of losses of this painting. So we have now good connection between past and future, between old painting restoration procedures, actually between old paintings and modern IT technologies. For the first view, it maybe can be impossible, but it's a real practical task that we try to solve, and we have some results which I introducing now to our participants. To do this, we use some methods of approach which we have seen on the bottom center part of the slide, such as region-based segmentation, clustering segmentation, and convolutional neural network. All of these approaches have known machine learning methods and approach. So we have receiving data, digitalizing them, then preparation this data for the next machine learning state, machine learning algorithm states. Then we should to choose algorithm for this process, execute them, and estimate our results. So let's overview some methods using in our work. First of all, in the central part of the slide, we have regional based. Sorry, regional based or thresholding approach, which can be used also manually to choose our threshold and to distinguish differ between the background or good part of our painting and features. Or in this case, it's losing part of our painting. And this method we can use for the manually estimate effectiveness of machine learning algorithm, such as in the left part of the slide, clustering-based algorithms. And actually, it was a K-means algorithm, which well known by specialists, and which can divide our image into 2 clusters, good and losing part. And of course, we use the known unit architecture for the convolutional neural network, used as for the detection of damaged parts of the painting, but we trained this neural network to solve our task, which was to detect the physical losses of our old painting. And we can see the results. So we can see in the upper left part of the slide is the original image, and other part of the slide represents the results of used methods of our research. As we can see, the clustering-based method and convolutional neural network have a good results, but sometimes thresholding methods can be failed because of small difference between good and losing parts. At the end of my short speech, because of long time of our conference and weekend, I can represent the conclusive tables which compare these used methods. As we can see, the efficiency of clustering method could be good if in some cases, but for the other cases, we can receive more than 5% errors. So in this situation, it's better to use convolutional neural networks, but to train these networks, we need to have a lot of examples to receive good results, which have received at the level of 95% during our research. Thank you for attention, and if you have a question, please do that.
Thank you for a very interesting report. Have you questions, colleague? No questions. Okay, thank you very much. And next, I want to invite to speak our participant, Mikhailo Popov, Sofia Alpert, Maxim Alpert, Alexander Zaitsev, Ruslana Stambirska with report, our final report today, a method to ranking reliability of sensors of multi-sensor system interval valued number case.
Good afternoon. My name is Alpert Sofia, and I would like to make a presentation. The topic of the presentation is a method to ranking reliability of sensors of multi-sensor system, interval valued number case. Nowadays, nowadays, multi-sensor systems are applied for solution of various ecological, agricultural, and military problems. Sensors can differ in their precision, completeness, credibility, and other characteristics. The paper proposes a new method to assess information reliability of sensors. Method to ranking sensors, which is based on the idea that the information reliability of any sensor can be calculated based on estimates of the proximity of its data to the data of the sum ratio central sensor. The function of each sensor is to collect data about object of interest. We consider the case when probability assessments assigned by sensors for hypotheses are expressed as interval numbers. Each hypothesis shows the class affiliation of the test object. Theoretical information. Let's introduce some definitions. Interval valued number is a bounded closed subset where R is the set of real numbers. Tuple is an ordered set of interval numbers, P. Let's consider the scheme of ranking sensors. Let's consider this scheme in more detail. At first, we should normalize all tuples. We should check two groups of conditions for normalizing of interval numbers of the tuple. Let's consider this scheme of normalization. We have n interval numbers of the tuple. Then we check the first, second, and third conditions for the tuple. If these conditions are satisfied, we should check fourth and fifth conditions. If these conditions are not satisfied, we should conduct sixth and seventh transformations. Then we check fourth and fifth conditions. If these conditions are satisfied, we get normalized tuple. If these conditions are not satisfied, we should conduct eighth and ninth transformations. Then we should build prototype. Prototype is a virtual central sensor. Suppose that here is a set of sensors. Each sensor, E sub E, is represented by a normalized tuple X sub E, where component X sub EJ is defined as such interval, AEJ, BEJ. D is the interval dataset where tuples X sub 1 and X sub n represent sensors. We built the prototype virtual central sensor. The prototype G is a central tuple of P intervals with components G sub J. The prototype G of the dataset D has the boundaries of the interval G sub J computed according to 10th and 11th formulas, where the n is cardinality of the data set D. Next, the information reliability of each sensor of multi-sensor system can be calculated based on estimates of the proximity of its data to the data of the virtual central sensor. We calculate the distances between each tuple and the central tuple. The smaller the distance between tuples that describes some distances that describe some sensor and central tuple, the more reliable the sensor is. To measure the distances between the tuples in our research, three following distances are used: Wasserstein distance, Hausdorff-Chorin distance, and Euclidean distance. Let's consider following numerical example. The results of this example were obtained by developed software. It was used C# language with default tools. Let's consider the case when we have three sensors. We denote them as first, as second, and as third that are described by such tuples X sub 1, X sub 2, and X sub 3. These interval numbers of tuples are normalized according to the procedure described by such formulas 1 and 9. Then the central tuple prototype is calculated according to the 10th and 11th formulas. And we get the G, the prototype. Then the Wasserstein distance, Hausdorff-Chorin distance, and Euclidean distance between each tuple and central tuple are calculated according to the 12th, 13th, and 14th formulas. Next, the results are shown in three tables. Let's look at first table. The calculated values of Wasserstein's distance are ranked in a descending order, and ordinal statistics is constructed, in which the location of the distance value determines the information reliability rank of the corresponding sensor within the multi-sensor system. Then, in the same way, the values of the Hausdorff-Chorin distance and Euclidean distance are ranked too. We have first table for Wasserstein's distance and second table for Hausdorff-Chorin distance and third for Euclidean distance. Then, analyzing these results, we can make a conclusion that first sensor has the highest rank, so first sensor is most reliable. Second sensor follows first sensor, and the third sensor has the lowest rank, so third sensor is the least reliable. Then we can make conclusions. The new methods for assessment of the information reliability of sensors for the case when probability assessments assigned by sensors for hypotheses are expressed as interval valued numbers was considered. The proposed method is based on the assumption that the information reliability of each sensor is determined by the distance value between this sensor and virtual central sensor. The smaller the distance between each sensor and virtual central sensor, the information reliability of the sensor higher. It also was shown that the results of ranking of sensors based on Wasserstein distance, Hausdorff-Chorin distance, and Euclidean distance are the same. The proposed method will be useful for assessment of information reliability of sensors operating under uncertainty. References and our authors: Mikhailo Popov, Sofia Eipert, Maxim Eipert, Alexander Zaitsev, and Rusvana Stambirska. Thank you for attention.
Thank you for a very interesting report. Have you any questions, dear colleagues? No questions. No questions. Good. No, it's all for today. I thank you all participants for your time, for your work, for very, very interesting report, for track information technology and artificial intelligence. It was a very good day today for us all. Maybe our chairman, Alexander Ivanovich, say any words? Alexander Ivanovich, would you like to say any words for our participant?
Thank you. I'm not ready. I can photo on the screen.
No.
Sorry. I sincerely wish you creative inspiration and your scientific achievement.
Thank you very much. Okay, I think we can our track for today complete, and I close our meeting. Thank you very much. I wish all health, happiness, and good luck.
Thank you all for the great conference.
Thank you.
Thank you.
Take care. Stay safe.
Thanks a lot. Yeah.
Thank you.
Thank you.
Thank you very much.
Thank you very much. For next meeting.